then which of the following is are correct? Okay, now let us see the options. Here you see the first option. For each G belonging to capital G, there exists H belonging to G such that H inverse sigma H equals to G. So let us first see the option A, whether it is true or false. For that, let us see here. You see here, here you see the option A in this for each small g belonging to capital G, there exists H belonging to capital G. I will show this taking going in the reverse direction. I mean, I will assume for all H belonging to G. Thereafter, I will again go in the reverse direction. Okay. So, suppose for all H belonging to H, obviously H inverse will be in G. Okay, and sigma H, that is mapping of H. You see here you see both the groups are same, so sigma H also belong to Z. Okay, and you know from the properties of group. Okay, H inverse rho H will be in G, and suppose H inverse rho H equals to G belonging to capital G. So so far we have proved that for all H belonging to G, H inverse sigma H belongs to G. Okay, now I will go in the reverse direction. Here you see the options. In the option, this was written in reverse direction. In the option A, you saw that there was for every G, a small g belonging to capital G, there exists, okay, H, such that H inverse sigma H equal to Z. Okay, so but here you see the homomorphism is bijective. It ensures that this is an isomorphism, and in an isomorphism many elements of this G do not map to one element of letter G, letter capital G. Okay, one element maps to only one element. If you think in the reverse direction, then you will observe that every G, a small g belonging to G, will have such H, an element H, such that H inverse sigma H will be in G. Okay, so we go in the reverse direction considering two things. First is this mapping sigma, and this is an isomorphism. Second thing is that both the groups are same. See in the red circles, both groups are the same. So we so far concluded that our option A is true. So this option is true, and let us now use this relation. Actually, in this type of questions where there are multiple options, multiple true options, generally the options are related. So from this relation I can write rho h sigma h equals to hg. Okay, now I impose rho sigma both sides. Okay, so the next step will be equals to hg. Okay, now if you have observed in the question there are two conditions, and in the second condition, according to the second condition, this will be, according to the second condition, this will be h. So the next step is h, and due to homomorphism this will be rho h into rho g. Okay, and again for this I can write hg. Okay, so I am doing the same. Here will be hg, and you have h already here, and here will be rho g, and from this you get g inverse equals to rho g. So we have got the mapping. So I write the same thing afresh. Okay, so the next step will be rho g equals to g inverse. If you replace g by x, then this will be rho x equals to x inverse. So our option C is true, and since C is true, then B will be false, because if you multiply this relation both side by x inverse, then you will have rho x is not equals to x inverse. Sorry, not multiplication, the group operation, precisely, if I say precisely, the group operation. Okay, so here this is not correct. Here it will be x inverse. Okay, so here it says, here you see it says sigma x equals to x inverse, and here you see the opposite. So B is wrong. Okay, now I go for the last one. For that I erase all these things. The last one here, the last one is the order of the group G is an odd number. So to prove this, we assume opposite to this statement. I mean, let the order of G is an even number. Okay, even number. So there will be at least one non-identity element say x, for which x to the power 2 will be an identity element, because 2 is the smallest prime number dividing any even number. From this, the next step I write erasing this thing. Okay, the next step will be x equals to X inverse, and you know our relation is this one. So according to this, because this is a true statement, here you see C is true, so using this I can write the result we get x equals to rho x. Okay, but in the question, if you see the question, in the question the first condition is, you can go back in this video and can see the question. In that question you will see the first condition. Whenever rho x equals to x, then x equals to identity element. But we have assumed, when I started to check whether option D is correct or not, I assumed that x is a non-identity element. But here we got the contradiction. We got x an identity element. So our assumption that G is the order of group G is an even number is wrong. So the order of group G is an odd number. So our option D is also correct. So we have three options, three correct options, A, C and D.